Here we go. Day 4. Day 4. Hey, did I tell you guys what our test is going to be?
Friday.
Clearly you did not.
I think it's Friday next week. Okay? Friday next week's going to be our test. Shh. And then we're going to have like 7 class periods to study for the final.
That's a lot.
It's a lot, right? A little excessive. But, hey, speaking of the final. Yo, did everyone get that final exam review packet we handed out before break?
No. Yes.
If not, see me at the end of class. I'll make sure you get one. If you have started to work on it, you want to check some of your answers, I have some of the answer keys printed off. So you're more than welcome to come up, get one, look at it while you're in here, but it doesn't leave. So I need them for all my classes. Cool? Alright, let's do this. So, we've talked about how we solve all sorts of different things. We talked about solving by substitution, by graphing, by equivalent forms, by combination elimination. Today we're talking about word problems, application problems. So, to solve an application or word problem using a system of equations, first of all, we're going to define our variables. Right? What is x going to be? What is y going to be? Do you have to use x and y? No. I will use x and y 99% of the time just because I like to. But you do not have to use those two variables. As long as you define what your variables are, I don't care which ones you use. Okay? So if we look at our problem here, we're going to do this problem as we go along. So, imagine you've just started a new summer job in an office. It's your first day of the job, and the boss is sending you to pick up lunch for the 23 people who work in the office. Turns out that everyone wants either one hot dog or one hamburger, so you can't have more than one. You get a hot dog or a hamburger. You arrive at Pop's to place your order and realize you forgot to write down how many of each you're supposed to get. You see that hamburgers cost $1.50 each, hot dogs cost $1.10 each. Tax included, and you're given $32.10. You're given the exact change. How many hot dogs and how many hamburgers were ordered? So first of all, we need to define our variables. What do you think our variables might be in a problem like this? Hot dogs and hamburgers, right? The two things we're looking for. So I'm going to let x be hot dogs. X equals number of hot dogs. And y equals number of hamburgers. Also, hot take, hamburgers are better than cheeseburgers.
Disagree.
Just saying.
Costco hot dogs are better
You're
than
just
Costco
wrong.
hot dogs.
No, I'm not wrong. I'm never wrong. You should put that down. Alright, step 2. Write a system of equations. So, there should be 2 different pieces of information given in your problem. Each one's going to be used to write a different equation. Right? So we're talking about 2 separate types of things. Like in this problem, we're talking about the quantity. Like there's 23 people and everyone gets one hot dog or a hamburger. Right? That's a quantity of things. The other thing we're going to talk about is the money. So you should look and see, well, I know there's a money portion and a quantity portion. Each one's going to have its own equation. Right? So if I think about it, how can I figure out how much money I'm using for this? Right? Well, how much money was I given in total for the order? $32.10. So I know it's going to equal $32.10. Well, I got to figure out how are my variables fitting into that. Well, how much does a hot dog cost? $1.10, right? So $1.10 times every hot dog ordered, or X, plus, how much does a hamburger cost? $1.50. So $1.50 times Y, or however many hamburgers are ordered. So that's our money equation. Our second equation is going to deal with the quantity of things. Right? We're talking about everyone gets one hamburger for one hot dog. Well, how many people are there? 23. Well, how do I figure out the other part of that equation? X plus Y, right? Should be the number of hot dogs plus the number of hamburgers should add up to 23 because everyone only got one. Well, if you look there, I now have a system of equations, right? I have something I can go ahead and solve now. And that's going to be step 3. Solve your system. Use whatever method you want. Use combination elimination. Use substitution. Use equivalent forms. Use graphing. I don't care. If you want graph paper, I will gladly give you graph paper to do every single problem. That's fine. If that's the one you want to do it. I'm going to use combination elimination because they're both already written in standard form. And that's just, I think it's going to be the easiest for this problem. Like I said though, you do you. Do whatever form, whatever solving form you want to do. Alright. If I want to do combination elimination for this problem, what could I do?
Multiply by 1.
What's that?
Multiply by 150
Why would I multiply by 150?
to get the y's equal, or negative 150
Okay, so I multiply by negative 150 here to do what?
to get the y's opposite.
To get opposite coefficient for my y values. Very good. So I'm going to multiply that second equation by negative $1.50. So my top equation stays the same. Okay, then I should get negative 1.50x minus 1.50y equals, that should be 3450. Negative 3450. Right? Someone with a calculator, please check that. Bueller?
Yes.
It is? Okay, thank you. Alright. So, once I've got opposite coefficients, I'm going to add them together, right? So I can eliminate a variable. In this case, my y's get eliminated. I'm left with negative 0.40x equals negative 2.40. Right? Add my x's, add my constants at the end, and then what do? Renee, what do? Can you help me?
5.
Divide. Just by anything?
Negative 0.4.
Negative 0.40 or negative 0.4. Good. I should get x equals 6. Sweet. That's my first part. Second part to solving this is then plugging that back in to figure out your y value. Well, if I plug it in, I get 6 plus y equals 23. Subtract 6, I get y is 17. Now, how do I write my answer normally? As an ordered pair, but look what step 4 says. Write a sentence to answer the question. Alright, so we want you to write it out. Tell me, what is our solution? Well, X stands for number of hot dogs, right? So I'm going to say, ordered 6 hot dogs and 17 hamburgers. Does it need to be a perfectly grammatical sentence? No, I really don't care. Right? But make it a sentence. Don't just put 6 hot dogs, 17 hamburgers. Right? Give me some sort of context to it, please. Okay? Does that make sense? Some people look so confused.
I just don't want to write order.
All right. Do we have any questions on that problem, guys? Okay. Then I believe there's one more problem we're going to do. It says for you guys to try it. Let's read through the problem first. Let's talk about something, and then I'll let you go ahead and try it, okay? So, Marvelous Maryland scored 273 points last season for her high school basketball team. Her points resulted from a combination of 2-point shots and 3-point shots. She made a total of 119 shots. How many of each type of shot did Maryland make? What are our two variables going to be here? 2-point shots and 3-point shots. So you got to figure out x is going to be one, y is going to be the other, or whatever you want to use as a variable. Okay? Do you think you can do it from here?
Yeah.
All right, go ahead and try it. In a couple minutes, we'll go through the two equations, and then if you're still stuck there, I'll give you some more time to work. If you do have a question, please make sure you ask. Don't just sit there and bang your head off at the table because you don't know what's going on. How you guys doing? Good? How are you doing? Questions? Okay. Alright, so you can check with what your system should have looked like, 2 equations. You can check your solving. And make sure you write a sentence out, right? Marilyn should have made 84 2-point shots. You should have made 35 3-point shots. Alright? Are there any questions about how we go about any piece of this? The writing them, the solving them, the answering the question, anything? Do you want me to leave that up there for a couple minutes? So I can do that. Alright, I'm going to hand out the homework. Guys, remember,